Integrals of some particular functions. In previous videos, we studied about different methods of integration. The first one being the method of substitution, and the second one or the previous one we studied about integration by using the trigonometric identities. Now, what are these different particular functions in integration? Let's look at them. Before that, let's start with an example, which is what is the derivative of tan inverse x? What is the derivative of tan inverse x? We know that it is 1 by 1 plus x square, right? So if I take the integral 1 by 1 plus x square dx, what I will get? I will simply get tan inverse x plus c. So this is the derivative of tan inverse x, that is 1 by 1 plus x square, or you can also write 1 by 1 plus x square has an integral of what? Tan inverse x plus c. Now instead of this 1 by 1 plus x square, if I write in general, what is the integral of 1 by a square plus x square dx? What is the integral of this 1 by a square plus x square dx? Now that is what we are going to see in the coming session. So let's write this down in the next page. So I have integral 1 by a square plus x square dx. Now how to integrate this? So to integrate this, I am just going to use the method of substitution. That is, I am going to put x is equal to a tan theta. What is the substitution that I use here? X is equal to a tan theta. So if x is equal to a tan theta, what is dx? Dx is equal to a sec square theta d theta. So what is dx? A sec square theta d theta. So now this dx can be written as a sec square theta d theta, and the x over here can be written as a tan theta. So I can write it as 1 by a square plus x square is a tan theta the whole square. So that is a square tan square theta. Yes, and dx becomes what? A sec square theta d theta. So I will be getting integral a sec square theta d theta by a square plus a square tan square theta. I can take a square common and write it as 1 plus tan square theta. Okay, and this is a sec square theta d theta by a square. What is 1 plus tan square theta using the trigonometric identities? It is a square sec square theta. So these two gets cancelled and you have a by a square, that is 1 by a. So that 1 by a comes outside and you have only d theta left. What is this d theta? Integral d theta, it is theta. So 1 by a theta plus c. Now we use substitution, so we have to go back. So x is equal to a tan theta means x by a is equal to tan theta, or theta is equal to what? Tan inverse x by a. So theta is equal to tan inverse x by a. So I can also write this as what? 1 by a tan inverse x by a plus c. So what is the integral of 1 by a square plus x square? It is 1 by a tan inverse x by a plus c. So this is how we find the integral for this particular function, that is integral 1 by a square plus x square dx is nothing but 1 by a tan inverse x by a. So this is one particular function, right? Now, not only this, there are different particular functions that we have to study, and let's look at each one of them, the following. So the first one, as we discussed, is integral 1 by a square plus x square dx. So what is that? It is nothing but 1 by a tan inverse x by a plus c. Then we have integral 1 by x square minus a square dx. The value for this one is 1 by 2a log mod x minus a by x plus a plus c. So this is also another particular functions integral. You have to by heart. Maybe this by hearting might be useful in solving questions, because we don't need to solve every time by substituting x is equal to a tan theta as we did in the previous 1 by a square plus x square. So by heart this one for 1 by x square minus a square, that is 1 by 2a log mod x minus a by x plus a plus c. And now the next one is integral 1 by a square minus x square dx. So the integral for this one is 1 by 2a log mod a plus x by a minus x plus c. So this is the integral for 1 by a square minus x square. So now what is the integral of 1 by root of x square plus a square dx? So the integral for this one, 1 by root of x square plus a square, is nothing but log mod x plus root of x square plus a square dx plus c. So this is the integral for 1 by root of x square plus a square, and the same goes for 1 by root of x square minus y a square dx, that is log mod x plus root of x square minus a square. So this one is for 1 by root of x square plus a square and 1 by root of x square minus a square. So these are the different particular functions, integrals that we have to always remember or always by heart. So I hope you have understood this one. Please write this down during this video itself. You can pause the video and write this down. Okay. Now let's start with the second one. I'm not going to prove the entire particular functions. Just the second one I'm going to take again. That is 1 by x square minus a square dx, which is equal to 1 by 2a log x minus a by x minus a plus c. How did we get that integral? So what we can do for that? So look here, 1 by x square minus a square dx. What I'm going to do here is, I'm just going to multiply and divide it by 2a. So what I do here is, I multiply and divide it by 2a. So you have this one over here. So 1 by 2a into integral 2a by x square minus a square is what I got. Now 1 by 2a, this 2a on the numerator can be written as a plus a, by x square minus a square can be written as x plus a into x minus a dx, right? Yes. So if I write it like this, can I also write the numerator a plus a as x plus a minus x plus a, because I'm adding and subtracting an x. So I'm adding an x over here and I'm subtracting an x over here. Yes. So if I do that, I'll be getting 1 by 2a x plus a by x plus a into x minus a plus a minus x. A minus x, I can also write it as x minus a and put a minus over here. So minus x minus a by x plus a into x minus a dx, right? Yes. So now can I cancel this x plus a and x plus a here? X minus and x minus over here, and I get 1 by 2a integral 1 by x minus a minus 1 by x plus a dx. Now what is the integral of 1 by x? Log x. So what is the integral of 1 by x minus a? It will be 1 by 2a log mod x minus a minus, what is the integral of 1 by x plus a? Log mod x plus a plus c. Now what is this 1 by 2a log mod x minus a minus log mod x plus a? It is log mod x minus a by x plus a plus c. Now is this the same that we got before? Yes. So this is how we find out the integral for 1 by x square minus a square dx. Now if I ask you what is the integral of 1 by x square minus 7 dx, can we write 1 by x square minus 7 as integral 1 by x square minus root 7 the whole square dx? Yes. Now it is of which form? The one that we just studied, that is 1 by x square minus a square dx is 1 by 2a log mod x minus a by x plus a plus c. So if I do that, I will be getting over here 1 by x square minus root 7 the whole square, I will be getting 1 by 2 root 7. In place of a, I have root 7. So 1 by 2 root 7 log mod x minus root 7 by x plus root 7 plus c. So this gives us the integral for 1 by x square minus 7 dx. So that is how we got the integral easily. We have a formula, we use the formula, we substitute the value of a, and we finally get the answer for this particular function. Now in the same way, if I take integral 1 by root of x square plus a square dx, we have studied a formula for integral 1 by root of x square plus a square dx, that is log mod x plus root of x square plus a square plus c. So how can we get that formula? So here also I am going to put x is equal to a tan theta. If x is equal to a tan theta, what is dx? It is a sec square theta d theta. So putting all this, I will be getting a sec square theta d theta divided by root of x square. In place of x square, I will be having a square tan square theta plus a square, and that is nothing but integral a sec square theta d theta divided by root of a square tan square theta plus a square. So I can take inside root, I can take a square common. So when I take it outside, I will be getting a, and inside I will be having tan square plus theta plus 1. Tan square theta plus 1 is how much? Sec square theta, and the root is sec theta. So I can take sec theta outside. So a and a gets cancelled. You have integral sec theta. When you divide sec square theta by sec theta, you have sec theta d theta. So this is what I get. Now what is the integral of sec theta? We have not studied that. Integral of sec theta is nothing but log mod sec theta plus tan theta. So this is the integral of sec theta. So if I write that, I will be getting here integral sec theta d theta will be log mod sec theta plus tan theta plus c. Now I cannot leave it like this. I have to finally write the answer for this one. So what is sec theta? If x is equal to a tan theta, if I put theta over here, what is tan theta from this one? Tan theta is equal to x by a. So this is x and this is a, and this is root of x square plus a square. Now what is sec theta from this one? Sec theta from this one will be root of x square plus a square by a. Root of x square plus a square by a. So this will be root of x square plus a square. Sec theta will be that. So log mod root of x square plus a square by a plus tan theta will be x by a. So x by a plus c. Now there is an a which is common in the denominator for both. So I can take it as log mod x plus root of x square plus a square. The whole divided by a, I can take it as minus log a. So minus log a plus what do you have? The constant, that is c. Now log a is a constant. Constant is also a constant. So you combine these two and you can also write this as what? Log mod x plus root of x square plus a square plus c, which is the final integral for this particular function. Understood? So this is one way of writing 1 by root of x square plus a square also. We have written it in this form and we got log mod x plus root of x square plus a square plus the final constant, that is c. Now we have a question over here to find the integral dx of dx by 2x square plus 3x plus 5. So here directly can we do this particular question? No, because it is in a quadratic form there in the denominator, but it is neither of the form x square plus a square or x square minus a square or anything. You have 2x square plus 3x plus 5. You have a quadratic x, a linear x, and there is a constant term. So you cannot directly do this. So what I'm going to do here is, I'm taking this 2 outside. I'm taking it as 1 by 2 dx. You have x square plus 3 by 2x plus 5 by 2. So this is what you're left with. Now you see the middle term, that is 3 by 2. What is the half of the middle? 3 by 4. What is the square of that? Is 9 by 16. So what you do is you do the completing the square method you have learned in polynomials or quadratic polynomials in 9th standard. So you do that over here, half of integral dx by x square plus 3 by 2x plus 9 by 16 plus 5 by 2 minus 9 by 16. And once you have done that, you will be getting 1 by 2 integral dx by, what is x square plus 3 by 2x plus 9 by 16? It is x plus 3 by 4 the whole square. Plus 5 by 2 minus 9 by 16, I can write it as 8 multiplied by this one. So you get 40, 40 minus 1, 40 minus 9, that is 31 by 16. So that is what you get here. Now I can write it as integral, half of integral dx by x plus 3 by 4 the whole square plus 31 by 16, I can write it as root 31 by 4 the whole square. Yes? Yeah. Now, is this of the form 1 by x square plus a square dx? Yes. And what is the integral of that? 1 by a tan inverse x by a. So now it is of this form. That is, in place of x, you have x plus 3 by 4, and in place of a, you have root 31 by 4. So can you write the final answer? That is, there is a half outside. So half of 1 by a. In terms of a, you have root 31 by 4. So 1 by root 31 by 4 tan inverse x plus 3 by 4. X plus 3 by 4, I can also write it as what? 4x plus 3 the whole divided by 4 divided by a, that is root 31 by 4 plus c. You can cancel this 4 and this 4, and this one, this 2 and 4 you get cancel, and this 2 goes up. So you have 2 by root 31 tan inverse 4x plus 3 by root 31 plus c. So that is the final answer for this particular question. Understood? So we have used which one? The particular functions that we have learned now. The question actually did not look like that, but when we converted it using the quadratic rules, completing the square methods and all, we got a form of 1 by x square plus a square, and we integrated it. I hope this was useful to all of you. Now, there is one thing that I want to tell you guys, that is, you know that integral 1 by x square minus a square dx is nothing but 1 by 2a log mod x minus a by x plus a plus c. That is 1 by x square minus a square. We also wrote this as 1 by 2a integral 1 by x minus a minus 1 by x plus a. This way. So that means 1 by x square minus a square. This x square minus a square can also be written as x minus a into x plus a. So as you can see, here there is a product of x minus a and x plus a. There is a product. And when it comes here, you can see that x minus a is separate, x plus a is separate. So that means a product is now separated into two individual fractions. How is it possible? And what is this type? This is nothing but, what do you call it as, the partial fractions. So what is this? Partial fractions. You have a product of denominators. You splitted that into two separate denominators, 2 or 3, how many may be. So you separated that into different denominators, and now the integrations becomes easier. Here the integration is not easy, but here the integration is easy. So when that is happening, what do you call it? You call it by the name integration by partial fractions, which you will be studying in the next video. Until then, keep exploring.
Manorama Horizon. Learning made simple.